Namaste. Welcome to this channel Chemistry Made Easy by Dr. Ashok Mulik. Today we will see the next part of this atomic structure, that is atomic orbitals and their nodal surfaces. So in the last lecture we have seen that the atom consists of the nucleus at the center, which is the showing major mass of the atom, and the electrons are present and occupying the large empty space around the nucleus. And according to the discussion we have carried out last time, we have seen that there are variety of atomic orbitals. So depending upon the principal quantum number, so if we consider the principal quantum number, then it has values 1, 2, 3, 4, etc. And the L values are starting from 0 to n minus 1. Then M values are from minus L to plus L for a given value of L. Then there are also the MS values, that is spin quantum numbers. So out of these, the first three quantum numbers are defining various characteristics of the atomic orbitals and explain about the energy, the location of energy, the total amount of energy associated with the electron when it is located at a specific space in the available around the nucleus in the atom. So we have seen that there are the L values, that is starting from 0, 1, 2, 3, etc. These values speak about the various atomic orbitals, and these atomic orbitals we have seen last time that they are defined as the 0 value for L indicates that it is S orbital. When the L value is 1, it indicates P orbital. When the L value is 2, it indicates the D orbital. So in this way, every principal quantum number or main energy level will have different atomic orbitals. So here we have to see here the structure of atomic orbitals, and these structures are showing the electron densities. Where is the probability of finding the electron is maximum in a specific atomic orbital, and what are the regions in these atomic orbitals which are showing the 0, psi square value 0 means electron density is 0. Actually the electron density is not sharply 0, but it is much less because electron is moving anywhere in the atomic orbital, and when the atomic orbital is divided into different regions which are separated by the nodal planes or radial regions of nodes, then we have to consider that electrons may migrate from one place to another, but we have to remember that still the nodal plane or radial nodes are there, because electron is considered having to have dual behavior, that it is acting like a particle as well as we are considering it like a wave, and wave can propagate anywhere very fast, so that the nodal region doesn't make any problem while considering the nodal planes or nodal radial spherical nodes. So in short, the nodal regions, that is nodal surface, is the region in the space in atom which is showing psi square value, that is electron density, as 0. So psi square means electron density is 0, and such region is called the radial spherical nodal surface. Or whenever there is no such radial region in the atomic orbital, there may be the planar region which shows electron density 0, means it is most close to the 0, that is the nodal plane. So here we have taken the diagrams for here. So we are considering here, you can imagine first, that is, this is 1s atomic orbital. So this atomic orbital has the nucleus at the center and the electron density is found to be maximum around this nucleus in a specific region. So that is called here this 1s orbital. So we have shown here this 1s orbital. Then the 2s orbital is like this, where 1s is comparatively, if we compare the size of the atomic orbital, this 1s shown here is very smaller in size, and the 2s is surrounding it, which is shown in blue color. So compared to the space occupied by these 2s, the space occupied by 1s, there is some empty space, there is some vacant space which is shown here and in the white color. So that is called the radial spherical node in the radial form. So here we find that this region is here. So this is called the radial node number 1. Then if we consider the 3s orbital, it is having also the same structure, that is 1s at the center, 2s is around it and having the nodal one, radial node number 1. But after these 2s, there is again some empty region, that is the electron density is 0. So that is called a second radial node. And this red color of space is showing this 3s orbital. So this is red color of space showing 3s. The blue color of space shows 2s, and again the red color in the center shows 1s atomic orbital. Similarly, the 2p orbital has shapes like this. The colors are different. So these are presenting their signs of wave functions. Say one is plus, another is minus. Then that will be discussed later on in detail why it is plus 1 or minus 1. So for here we are considering this 2p having two regions of atomic orbitals, but there is no separation in between them, so there is no nodal plane. So nodal plane is absent here. In case of 3p, you will find that this 2p is already there and it is further covered by the 3p orbitals. One is in red color and this is in blue color. And in between the 2p and 3p, there is some empty region where the psi square, that is electron density, is 0, and that is called the radial node. So that is called the radial node. You will see here this radial node in this way. So you will find that this inner 2p is here and outer 2p, that is 3p, which is also shown here 3p. So this 3p is shown in blue color. So there is nodal region or surface in the circular form, or we can say in the spherical form. It is in the spherical form, so it is called a nodal radial surface. So this type of atomic orbitals are shown in thick color form, but these are also shown in this way, and these are also shown having the radius here. Now here you will see that the chlorine, if we take the example of chlorine, it has 2pz, it is like this. So it has two regions here occupying like this. So you can see this is the inner region. So there is some empty gap. There may be some empty gap. So these are very larger regions, and in between there is a line called this nodal plane, where we consider or where we find the electron density is to be 0. So that is called a nodal plane. So this plane, this orbital is shown along the z-axis. Similarly, you will have also orbitals of p nature, that is px and py, in the same form, having the same type of nodal plane or nodal planar surface. So the distance between this nodal plane and about this outer region of this lobe, we say. So these are two lobes of this atomic orbital. Means two regions. Two regions are called two lobes. So this is the distance considered here is 1 angstrom. This distance is also considered here to be 1 angstrom. Then you will see here 3p z orbital. So 3p is like this, where there is 2p inside shown, and the outside regions are actually 3p orbitals, 3p z orbitals. So here in between this 2p and this 3p orbitals, there is the nodal radial and means spherical region or spherical surface which is having electron density 0. Then if we go to consider the d orbitals, we have not shown here d orbitals, but we are showing here this d orbitals. Out of these d orbitals, we know that there are 5 d orbitals, out of which we will take this first 3d z2 orbital, 3d z2 orbital, where we know that the value of here the m is 0 when the L values are considered here. Right? So this 3D has this z axis and this x axis. So with this structure you will find that these are the black color spots, indicate that these are the centers of these lobes. You will see these are the lobes. Now here is also the center of this lobe. So you will find that these are the two lobes and these are other two lobes. So the two lobes which are lying in the direction of z-axis are relatively larger in size, and the two lobes which are lying in the xy plane, this is along the x-axis, but there is also one axis, that is y-axis perpendicular to it. So these two lobes are present around this center in the circular form. That is, these two lobes are actually reduced in the two ring-like structure, and because of this there is much gap between the two lobes. There is also much gap between these two lobes. I mean, these two lobes are actually present in the circular form, which are in the one form. We have shown the cross section of this orbital in the direction of x and z axis. Means the cross section of this orbital is taken in the zx plane. The cross section is taken in zx plane, and that is why we are showing these orbitals as separate entities, lobes, as these two lobes are not actually separated entities, but these are connected together. These are like a ring of Saturn. We can consider the planet Saturn. There is a ring. So in that way, these two lobes are present around the center of this atom in the circular planar ring-like structure. So in between this ring there is some gap. So actually means the nodal plane is not available. A nodal surface is not available along any x and z axis. It is not available along any x, z and y axis also. But it is available in between these lines, or the line between z x axis or Z and this x-axis. So there are two lines which are indicating these are nodal planar surfaces. So this is the observation in case of 3D Z2. Now we will see another lobe, that is 3D x2 minus y2. We have taken the example of again 3 plus iron here. So this 3D x2 minus y2 has four lobes of the atomic orbital. Out of four, two are oriented in the direction of y-axis. They are oriented in the direction of y-axis. So this is the cross section taken along the xzy plane or yz plane. This is the cross section of this 3D x2 minus y2 taken along the yz plane. So we are finding that the two orbitals, the lobes of the atomic orbital are two, and these are lying in the direction of y-axis. There are two more lobes which are lying in the direction of x-axis. So here you will find the 3D x2 minus y2, same orbital, but the cross section is taken along the xy plane. The cross section is taken along xy plane. So we are getting the four lobes of this atomic orbital 3D x2 minus y2. So we can find the region, this region. So there are two planes separating the atomic orbital into four zones or lobes. So these regions are having chi-square value 0 or electron density 0. So we are considering that these are the nodal planar surfaces. These are nodal planar surfaces. So this is about also 3d(x2 minus y2). Then there are also other atomic orbitals which are having present, means 3dxy, 3dyz, 3dzx, etc. So in this case, the nodal planes, there are also four lobes, but these four lobes are separated from each other by means of the nodal surfaces which are lying in the direction of specific axis, that is x-axis or y-axis or z-axis. Means any two orbital, if we consider it is dxy orbital. So the nodal plane is lying in the direction of x-axis and y-axis. When we consider the zx orbital, then the nodal planes are present in the direction of z-axis and y-axis. Then if we consider the x, yz or yz orbital, dyz orbital, then their nodal planes are lying in the direction of y and z axis. So in this way, we should understand that there are some regions in the atomic orbitals which are showing 0 electron densities. But there are some more regions. Now if we go away from these nodal planes in this direction, you will find the electron densities are increasing. So electron densities in these lobes are increasing as we move here away from this center. So there are these larger areas where electron densities are more. So these are larger areas where electron densities are more. So these are also colored areas, shows the regions where electron density, that is chi-square, is maximum. So with this we will stop our discussion here and we will go to the next point in this topic, that is what is above principle, in the next lecture. So till then, goodbye, see you next time. Please subscribe to this channel if not done. Please press the like button and bell icon, and you can also share your comments and put your requests for any special point if you need it. So see you next time. Thank you very much.